Okay, ladies and gentlemen, um, welcome to the presentation. It's called Who Are You? Maybe we can acquaint ourselves over a beer, but right now we're doing it in the context of our applications. I'm going to talk about identity access management for our PAS-OE product, our via OAuth2 and OIDC. My name is Bronco Oostermeyer. That's how you pronounce it, actually. For those of you who were in the general session, I'm in the 50% category. I'm doing this for 27 years right now, and I think a lot of us have gone a long way with our applications. I work for a company called Flesso, long-time sponsor, I think a well-known name. We are the biggest OpenEdge consulting firm nowadays, and we deal with a variety of technologies. And one of them is IAM offering, identity access management offering, and we use a product for that as well, but we get to that later. Where do we come from? Like I said, I'm in the business for 27 years. A lot of you are a long time in business, and the way I see it, we used to have a lot of applications which solved all problems for an entire organization. We had large monolithic applications which were either host-based or maybe somewhere in the 90s client server. And I generally would say that there was a low security awareness. May not for all of you, but security was not that much of a deal back then because we logged in and then it was okay. And when we had multiple applications, most of the time every application had its own password. So you just say welcome 00 and then you're good to go. You could use that all for all your applications or maybe not. But when you look at it, we are shifting demands. We're 30 years down the road right now, and we are in a fast-moving world. We have a lot of new business requirements, and if you look at it, why are we having a lot of new business requirements? I don't know. Most in Europe countries have a shortage of labor right now, so we see an increased demand for digitalization, and that demands more from your applications, not only as being the central part of your organization, but just one of the parts of the organization. And we are opening up these applications in new ways that weren't there even when we first created the applications at all. I think about web-based apps, those kind of stuff, APIs where you open up your application. And not only that is inbound, but if you look at it from a different point of view, you have to connect to other applications as well, either via enterprise service bus or direct calls nowadays, microservices which are called directly. In short, we have to do with our application with scenarios which it haven't been designed for. So we have to look at it differently. We call it differently. We would say that would be all about digital transformation. And if you were a security officer in the 1995s, then your job was not that hard, I suppose. If you look at it nowadays, if you're a security officer, you have a lot tougher job. You got a lot of responsibilities. And you don't have to look in the papers for very long to realize that it's pretty scary out there, and you have to. And it's all about the responsibilities you have. You, with your application, in a general way, with your application, have a responsibility for passwords you are storing, but in the data in general, and you have to make every necessary measure nowadays to make sure that this data you have in your application doesn't leak anywhere and it's safe. If you look at the GDPR rules and the legislation which comes out of it, fines if you leak data and you don't and you do it in a way you are to blame, the fines can be pretty stiff. So that there's actually a business risk, not only reputation risk, but there is a business risk of not doing this the right way. And if you think, well, I got my, we're running this internally, and it's just my application, but there are other applications in your network as well, and maybe they can be hacked. And via those applications, those computers which are hacked, you may be vulnerable as well if you don't take the correct measures to protect your data. Now, in short, do you trust? And if you connect in a broader sense, do you trust everyone who connects to your application? If you build a front end for your own application or an app, it's maybe a little bit different than when you have an API, which allows any vendor to connect to your application. But are they worth that trust? Well, old school. Back then we had simple login screens. We had a username, we had a password. Most of the time, well, at least the ones I encountered didn't even have a policy. So you basically could enter anything, and either everyone had the same password or anyway. These solutions were all either via the underscore user table or homebrew via a separate table, a custom table. We had our trusted and beloved encode function, but there's one good thing about encode, which is it hashes, and hashing is destructive. So if you have a password and you hash it, you end up with something which is not readable and not reconstructible back to the original password, in theory. But that's a good part about encode, but it is lacking sophistication. So by that you can cause collisions, and a collision is pretty simple. If you have a hash and that you don't know the password, you could devise a new algorithm to come up with your own password, which leads to the same hash, and that's what I call a collision. And that's not entirely unthinkable with the encode function, because it's just, like I said, it lacks sophistication. Well, next level, I said next between quotes, because it's the situation we're dealing with is not new. It is not like security has been invented, the need for security has been invented in 2023. But we came a long way with these hashing functions. Some of you may know, or all of you may know, MD5 and SHA1, which are also already insecure, considered insecure, because of the possibility of collisions. We have some more safe SHA 256 and 512 variants, which are okay. But and if you look at it from an OpenEdge pure perspective, we got a client principle, which is also a way of at least showing the back-end side that you are someone you are telling to. We'll get to that later. Just a little sidestep, because I do think it's interesting. If you, about these hashing algorithms, you can do whatever sophisticated hashing algorithm you can use, it doesn't matter. If you, in this case, for example, I'm hashing the password with this piece of code, I'm hashing the password of progress, the word progress. Well, that leads to a 32-byte string, and you would say, oh, that's pretty, sounds pretty safe. But it's actually not, because there are just rainbow tables, which are endlessly long tables. So like, if you got this hash, then this was the password which was used, and this, and that's not theoretical. The screen on the bottom right is actually an online password cracker. So what I did, I copied the SHA, the hash, copied it, and when you look at the green bar on the bottom right, it says progress. This is just online. So even when you use the correct algorithm, you're not safe yet. So and therefore would be nice to add something which we call a salt. And salt is basically, well, maybe a fancy word for just adding a string. So you could, in theory, add this string, which is a GUID, and then rainbow tables will no longer apply. There's only one thing which is still a bit of an issue, that if you use this mechanism, if two users have the same password, progress, they end up with the same hash. And I recently encountered an application where there were 50 users and 30 users had the same password. I could just read it out of there. Thus, even with sophisticated hashing, you're not there. Best way to deal with this would be to have a separate salt for each user in the user table. And that way, users which have the same password don't end up with the same hash. So you can't read. So if you have the same password as the director of finance, you can't see it in the database, which should be a bit of a relief for the finance director. And well, a lot of times he's the guy who's paying for the IT bills, so it's a good argument, I would say. But since this was about identity management, let's move away from DB passwords, because the DB passwords still give you the responsibility to deal with it. And nowadays we have mechanisms just to move that responsibility away from your application to a different product which is specialized and which you can utilize in order to do the authentication stuff. Which means and those specialized products are way better in implementing authentication than you and I possibly are ever going to be. So you don't have the responsibility, you have a good industry-wide standard, and you don't have to spend the time. And that deals with situation where you are not able to trust whoever consumes your application. Enter OpenID. These are the mechanisms I'm going to talk about today, and implementing them along with PAS and OpenEdge. OpenID and OAuth2. OIDC, which stands for OpenID Connect, is the container for both authenticating and authorization. So authenticating is just the login, and authorization is what roles are given to you. The authorization part is handled by OAuth2, and but these terms are mostly used interchangeably. So when somebody says OAuth2, maybe is talking about a scenario where there's logging in, authentication is involved as well. So for the sake of the argument, I would say that they are the same. Maybe to see what the OAuth2 part is all about, I think every one of you has sometimes tries to register for an application. It goes out to Google, log in with Google, and then Google comes back with a consent dialog, which says, do you really want this guy to have this and this information? Well, we call that a grant. We see an example here as well. And this is an example of a live demo, which I'm going to show you later. But this is the OAuth2 part. The OAuth2 is purely about authorization. Okay. If you look at such a thing, there's a lot of moving parts involved, and this is basically a picture of these parts. And I'm going to talk a little bit about the terminology which is used here, because it's important. If you can look, there are endless resources on the internet about how to implement this and what, but the terminology is important. So, and I would call it the OAuth lingo. And let's start with something which wasn't on the picture, but it's a protected resource. If you, of course, most of us make business applications, but if you have a photo on a website, on Instagram, for example, the photo you put over there is called a protected resource. And why is it a protected resource? Because it's yours. It's not, maybe everybody can see it, but it's why you put it on Instagram, but the photo remains yours. So that's what they call, in the OAuth perspective, call it protected resource. Now, these protected resource servers are served to the whoever wants to use it via a resource server. Sounds fancy, but in terms of OpenEdge, that would be PAS-OE. So PAS-OE serves the data you want. So I said a photo is a protected resource, but in this sense you can say the customer table or the order table or whatever your application is exposing is a protected resource as well. Protected resources are served by the resource server. Then there's the client. The client is the application which talks to the resource server. So it's not you, it's not a person, but it's just the web application. And as last, we got a resource owner, and that's one who is sitting behind the computer and which drives the client. It's called the resource owner. The resource owner of the protected resources. So the photos are yours and your. There's one thing which is was not on the list. The authorization server, which handles the authorization part, consists of two parts. It's the logging in, but it's the identities as well. And these systems don't have to be necessarily the same. So there is a possibility for an authorization server and a separate identity provider. And think of Active Directory, LDAP. Those are identity providers, but these LDAP and Active Directory don't provide you with the interface to actually be able to log in for web applications. And that's where the identity provider comes in. The resource server and identity provider can be the same, don't have to be. So again, this is the picture where it all comes along. Now, if you log into an application or an authorization server, if you are successful, you're handed over a token. And a token is a general concept, and it contains information about who are you, what are your roles, and very important, how long is this token valid? And keep in mind, these tokens are handed over to a client, and you don't know how they end up. So if you start dealing with these kind of scenarios, just be sure to limit the time to live of your token, because if somebody else grabs your token and it's valid for like 24 hours, you're handing them over the keys to your application for 24 hours, and you're going to not be able to do much about it. These tokens should be tamper-proof. These tokens contain identity. So, and you will see later on that these identities are just in plain text. And that sounds scary, but there's actually a mechanism for making sure that whatever is in the token is actually is signed, and that you know that's not been tampered with. So it's not like I have a token, I said the token says it's Bronco, and somebody comes along and said, well, maybe it's Hans. That doesn't work, because then the mechanisms no longer match, and I will talk to you about that later. These tokens are JWTs, Java JSON Web Tokens in OIDC. In OAuth2, there's a difference. The token can be anything, doesn't matter. OAuth2 doesn't say anything about the type of tokens. OIDC is a little bit more strict, and in general we use JWTs. But just from a conceptual point of view, a client principal we use in OpenEdge world is a token as well, because it carries identity, it has a time to live, and it is tamper-proof. Now, JWT consists of three parts. We get a header, which says something about the algorithm used to make this secure, the payload, and the signature. The signature, the payload is what it's all about, the information you want to hand over, so identity, and the signature is to make it safe. These three parts are separate JSON messages, and we hash these JSON messages and concatenate them with each other. So the X, Y, Z, and we separate them by a period. So entry 1 is the header, entry 2 is the payload, and entry 3 is the signature. Since these parts are just base 64 encoded, this implies that is just readable. So do not put sensitive information in your JWTs. There are secure versions of that as well, but from I would say as a general advice, don't put sensitive information in your tokens. These are readable, and whatever goes down the line, you should consider them readable at some point. So part of the security is on every level, so just don't do it. JWT sounds a little bit awkward to my, and we call it a JWT. Yeah, it's a little bit easier to talk about JWTs. The header contains some sort of metadata. There are two things which are basically important to type. Yeah, it's a JWT. Okay, that's what it's all about. It says something about the algorithms used for the signatures, and there's an ID as well. We come back to that ID later because that has to do with the information to make sure that it's all secure and with the signature. Now the interesting part is the payload, and the payload consists of it's a JSON message, key values, and these are called claims. So in OAuth 2 terms, you always read about claims, and think about information like expiration date, do not use before the audience, who's this token for, because the token, you can narrow it down who you're issuing a token for. Says information about the subject, and that's basically the person who's in there, whose identity is in the JWT. But the auth information as well. We look at an example here. For example, let's see who does it still work? Over here we see roles. Well, this is the authorization part, and this is more the authentication part. Because this is who I am, and this is what I am allowed to do. I'm a sysadmin, and I'm a PUC 2023 API user. Last part is the signature, and the signature is basically you take the first part, you take the second part, and you encrypt encrypt that, and you get the third part. And the third part is which tells that the first and second part is actually what it used to be when they were issued. So, like I said, you can't just alter a name or something because then the signature is no longer valid. And the resource server, which receives such a token, can verify that. Now, how to use them? These are typically used in an HTTP environment, so web applications or apps, or maybe a API. But these are sent down the wire via the HTTP header, an HTTP header, and it's called just the authorization header. And if you look at Chrome, F12, and then see what goes down the wire, this is how it looks. It's this authorization header of the type bearer, and then the entire string. And if you look at carefully, you will see somewhere the dots in between, and that's where the different part. But this is how it's sent down the line. But remember, this may look cryptic, but it's just based 64 encoded version of plain information. Now, how to get a token? Obviously, via the authorization server, and this is where things get interesting. OAuth 2 has several mechanisms of we call it the OAuth 2 dance of handing over someone a token, and it depends on two things primarily: on what kind of application you got. And a single-page application is not the same as a native app, and it's certainly not the same as an API. And it all has to do with the level of trust you have in the client. If you have your own web application, you're dealing with another thing than when you're dealing with your own native app. But most certainly, you're dealing with something different than when you have an API. Because if you have an API which everybody can subscribe to, which that implies that you can trust nobody on the other side. And OAuth 2 has different mechanisms of dealing with that scenarios. And one of the other things which are important and which lead to a different type of flow is the exposure of the token. In a web application, if you do F12 and you dig around a little bit more, you can probably pick up the token somewhere. And depending on whether that's a good idea, You have to have a different kind of flow. Flows are complicated. I put in a link. I'm not going to bore you with all the flows, but these are massive. There are a lot of interactions between both client and resource and authorization server before this actually is handing over a valid token. Which type of flow to use? I would say these sheets are downloadable in due time via the PUC website. I would certainly recommend this link for doing that, for reading about the flows. As said, the authorization server is handing over tokens. I would call it as a single source of truth for authorization. Now, what I said, every application has its own application mechanism, login screen and so, but that's not what you want. The ideal situation would be where there's a single authorization server for different applications in your entire organization. So you got one go-to point to go to your authorization, and you know it's taken care of, because multiple implementations means multiple headaches. Well, I already talked about the difference between an authorization server and an identity provider. The identity provider gives you the separations give you flexibility, because if you're an ISV and you want to do these kind of authorizations, you don't know, maybe you have an Active Directory on the other side, a customer with Active Directory, or maybe Azure AD or LDAP, which is one concern. But not every system administrator is willing to alter contents of its Active Directory, for example, with roles for your application. One says, okay, it's fine, I want to do everything in Active Directory, and some say, no, well, no. So that's where the separation of the authorization server identity provider comes in, because if you use the right product for your authorization server, you can put your application logic in there as well. Your application logic when it comes to roles, defining roles, and which users have which roles. You may not be able to do that via your Active Directory. And like I said, if you got 150 customers, they don't all have the same identity provider. So you're able to do this via authorization server. On top of here, I put Keycloak. Put in some more words about Keycloak, because that's what we use at Flusso for these kind of situations, which is basically an on-premise which we run on Docker, but you can have online authorization service as well. Most notably OAuth 2, Okta, Azure AD is obviously a big one. But in a way, you could say that the authentication, OpenEdge authentication gateway is an authorization server as well, although not very standardized one, but it is one. Why would you choose for either one of them? Well, assume you're a football association. You have a million members. And then maybe it's not a good idea to turn to Azure AD. Now, a lot of enterprise environments choose Microsoft, but there's a charge for every user. And if your user logs in once a month and you have to pay $3 a month to be able to register, then it's going to be a costly business. So that's where the other one come in, and that's part of the reason why we chose for a product called Keycloak, because we don't have a per user fee. Which makes it more interesting for our customers as well. Another thing is that the online authorization servers are big targets. Okta, for example, has been hacked. And that is a little bit, well, embarrassing, I would say. Because if you're hacked, then you're trying to do the right thing, and then the other guy screws up, basically. Now, like I said, we use Keycloak as an authorization server. It's being made by Red Hat, and they didn't make a product, and it's okay, that's nice, but they needed a solution for their own internal authorization. That's why it says dog fooding. They actually use it themselves, but they turned it over to the open source community, and whatever Keycloak is, you can just find it on GitHub. What was important for us is that the fact that it's extensible. We had to deal with a situation where companies had to log in with a government agency, and the government has some sort of OAuth mechanism, but it's just a little bit different. And there's no single product on the market which deals with that. But since Keycloak was extensible, we were able to write our own plugins to make this happen. And we said to the customer, which was the government agency, use Keycloak because it's extensible. And all of a sudden this use case came along, and we were able to incorporate that just because the extensible nature of this product. Like I said, it has a single interface for the various identity providers. So from our perspective, we're always dealing with Keycloak, and whatever is behind it, it's just one-time configuration, and then we abstracted it away. So we don't care whether it's Azure AD or it is Active Directory or LDAP or maybe even the social providers. We don't care. We have a single interface we can talk to. These kind of, don't know if everybody ever tried to make multi-factor authentication dialog in OpenEdge. It's kind of difficult. I would maybe impossible do it right, but with these products it's just a breeze, and I will show you later, time permitting. We deploy it via Docker. Once you come up with the right script, you can do it in 2 minutes. It's running in 2 minutes, so that's good for developers. You don't have to spend a lot of time. You don't have to have central instances. No, everybody can, for development purpose, can, if appropriate, can use run his own instance. What is also very attractive, there's a REST API for adding users. So let's say you have a big organization, you have an onboarding procedure, and somebody new employee comes along. You don't want to go to all these systems. No, you want to do it. You don't want to do that to HR. And it's got a REST API which is able to automate it. Now, just as a swift reminder, at Flusso we don't do products, so we're not selling it. We just think it's a good idea, and it's a good umbrella for the rest of this presentation to be able to talk about a concrete product. Now, about OpenEdge, talked a lot about generalizing stuff, but about OpenEdge. The resource server, what I already said, the resource server is, you can think that as PASOE. The protected resources, the customer table, the order table, or whatever you are adding to the equation. I'm going to show you a little bit later on in the demo with a client application, the client. That could be Angular, React, whatever. In this case, it was Angular. And we have the authorization server, which is Keycloak, which is just mentioned. Now, the key thing is here that the resource server, once you hit a URL, which you're not allowed to, this happens. So I created a little application which is called, which is a PaaS instance, and it's served on this URL, and this one represents the authorized part, the secured part. And if I just run this via just a browser or whatever Postman, I get a 401. 401 not authorized. And that's where the whole authorization journey starts. So the auth2 round trip, that's kind of important because it deals with one situation which we haven't talked about. The client application hits a 401, so it knows it has to log in. So this is just an error, but what's happening is that you as a client no longer present a login dialog. No, you make a request to the authorization server and say, could you handle login? So you are no longer, if you look at from a client perspective, you as the client, so the web application, never see the credentials and the password of the user who's trying to log in. That is entirely delegated to Keycloak, which relieves you of a big responsibility. Keycloak handles stuff, and Keycloak presents the login dialog and handles everything which comes along with it. And when that's successful, you are handed over the token, the JWT. But the important takeaway is that, we'll see that later, Keycloak handles everything, the authorization server. Now, once you get the token, you have the token to go to the resource server. You put the token in the HTTP header, as already mentioned, and you hit pass. But now there's one little thing left, because POS has to verify whether this token is valid, and this has not been tampered with. So that's where the signature comes in. The way to there are two ways you can verify a token. You can say, you can make an agreement that we sign this over here. The token is signed with a pre-shared key, but that implies that you have to make sure that the key here is the same as the key here, which, yeah, these keys can leak. Well, we got a better mechanism for it, and it's the same one is used for HTTPS, for example. It's private public key. So you sign the token, the signature. You come up with the signature. You do that via the private key, and then the resource server only has to have the public key in order to be able to verify whatever, if it's valid. Now, so there's one thing left. These public keys has to be fetched from Keycloak. And what happens? You just POS, because of Spring Security, POS makes a request to Keycloak, say, hand me over the public keys, and it responds with a lot of public keys. These things can change. You can shift, you can rotate the keys, whatever, to make it more safe, and that's where the KID, the key ID, comes in, because there are several keys handed over to you, and this KID field points to the right key you want to use, and then the mechanism. This, for an understanding, this is important. If you configure everything correct, this is all transparent. But I think, from a knowledge point of view, this is important. Once these things are verified, the PES converts the JWT. Fortio can do anything with a JWT. It turns it into a principal, and all the information in the JWT is available in the client principal as well. PES is a resource service, a little bit a short sheet. Tomcat based, because we're no longer having just an app server. No, we're a web server. And that's why sending tokens along with the HTTP headers is possible. It uses Spring Security, which is more or less an industry standard to handle these kind of situations. I think Progress did a good job over there, because it utilizes a lot of work of others to make this kind of situation secure, and they don't have to do it themselves, and POS is extensible as well. Now, if you have to configure this, we're going to talk about setting up POS. So one of the first steps is adding a web app, because if you create a POS instance, you have a root web app, and that's not secured, but maybe you don't want to secure it because there's other information which should be done down the line without authorization. I would recommend setting up a dedicated web application for these scenarios, because you can tweak the security information, the security setup for this specific client type. Well, this is more or less for future reference. This is how you deploy a web app to PES. And the next step would be, okay, I have this complete round trip, but I have a lot of pieces of information missing, because POS doesn't know where to go to. For example, the first thing is the client login model. You should switch that to OAuth 2. Normally it's anonymous, or no, I don't know, ORelm or something. In this case, it should be OAuth 2. you have to configure the audience. This is more or less, we can go through all the details, but this is more or less for reference later on. The audience is important because the audience, the token says, I sent you a token I created a token for this audience. Maybe you get tokens from PAS which you are not the audience for. For example, if you have 2 different web apps, you can both have different audiences. So maybe the web app gets a token for audience XYZ, whereas I configured that I only want to be interested in audiences of ABC. I tell you what the client is. The client is the client ID, so the client sends its client ID as well. And from an authorization point of view, the roles is what is important. This is a short jot, and here we got roles, and one of the roles is the PUC 2023 API user. But you have to tell PAS which of these fields are actually containing roles, because you can configure this to have any name. So these 2 has to match. For you as well, these 2 have to match. Next part is your web application serves routes, and you have to tell, you can configure per route who you want to authorize for that route. So I said it in this case. In this case, I say, well, whatever comes in /web, /web is what's handed over to all the web handlers. Is only suitable for the PUC 2023 API user. Now, since we already got it in our roles, this is good to go. If this one wouldn't be here, the PUC 2020 API user, then yeah, you were kicked out, and you still get the same 401 unauthorized. Thing is, this happens in PAS, in Tomcat. So it's kind of an early defense. Later on, if you breach this level of authority, you can go to the 4GL. Maybe you can see there. Okay, well, I'm trying to get the finance record of whatever, and you're not allowed. But thing about security is kick them out as early as possible. And this way, if you don't have the correct key, you'll never hit the 4GL, and that's important. Now, the second part is. This where it's a little bit complicated. We have to establish communications between PAS and the authorization server. Remember, the public keys has to be handed over, and it's done via HTTPS communication. And much the same as when you're trying to call from an OpenEdge, from the OpenEdge HTTP client to a secure website, you have to import the certificates to say, okay, you're okay to use this certificate. Well, the same mechanism applies for Java, and that's why we have to call a Java key store. It is a bit boring, but if you don't do this correctly, it's going to cost you a lot of time. And I can assure you I've been there, and it can go wrong for many little reasons. But the Java key store is basically the place where you store the certificates. And you have to put in 3 things there: the certificate of the authorization server, the intermediate certificate, and the certificate authority. Those 3, like I said, pretty much the same as for OpenEdge. You have to put in the Java key store. Well, this is a little bit details about how you obtain that key. Well, I think you can go to your browser, to the same URL, and then just make sure that you list the details of the certificate, and once you hit it, you can export it. Normally, there's a second option. Oh, there's a second option down here, which says export the entire key chain. So there's one file, and this one file you have to import that one. This is, like I said, for future reference. This is not something you can remember, but important thing is there is a password here as well, and this password is I think it's pretty ridiculous because you're trying to protect something which is openly available. But yeah, that's the Java key stores work. And this has a password, and but you end up with in this case a keycloak.jks file, which you have to put in this directory, or at least that's what I would recommend. You got your POS instance directory, you got a conf dir, and in the conf dir is a JWT keys directory, and I would say store it there because that's the most logical place. You can store it anywhere, by the way, because the next phase would be putting in your bin folder of your POS instance a set underscore set env, and a underscore set env is a way of adding environment variables to your POS instance and to Java. What we're doing here is telling where the JKS is located and what the password is. Like I said, the password is a little bit why I put it here just in plain text. The password here is irrelevant, but it's just a necessity because JKS requires it. If you do this in Linux, obviously there's a Linux equivalent well. Don't forget to put on the executable bit, because you can do everything right and it all seems okay, and then you spend 3 hours figuring out why it doesn't work, and then all of a sudden you realize, oh gee, I have a shell file, I have a script file, bash script file, but it doesn't execute, so it's not always obvious. Okay, finally, now we're going to the 4GL. When in the 4GL, well, like I said earlier, everything is turned into client principal, so all the information which is in the JOT is in the client principal. It's properties. Here's a little piece of code. Whenever you hit pass, and I do it in the activate procedure, we got this current request info get client principal, and that's the way you obtain the client principal. Now assume in this code, we assume this is valid. Doesn't necessarily have to be, but we assume it's valid, and we can list all the properties. In this case, we just list all the properties in the log file. Not entirely unimportant, we got the roles field as well, because the roles are put into the client principal, but that's where your application authorization starts. So the resource server doesn't know about the structure of your application. Now you apply, you can have a role as sysadmin, or as a finance reviewer, or a finance executive, and based on those roles you can do whatever you want in the application. So whatever you put in the JWT roles is here available. Sorry, no. It's in the client principal roles field, and that's where you, once you have this information, you should be able to do whatever your application requires from an authorization point of view. Now, just for reference, this is the entire JOT, which is a result of me logging into my little demo application. The bottom part is the identity part. We see the authorization part, and the rest is just a lot of telling how long is this token valid. And like I said, keep it down. Typically 5 minutes, no longer. There are mechanisms to make sure that the token, which is valid 5 minutes, can be refreshed in order to keep your things safe and don't expose too much. Now, demo time, because I think I talked enough by now. So let's start fresh over. And how much time do we got? 10 minutes, great. Here's the PUC client. This is an Angular application. This is all the pieces, the client, the resource server, and the authorization server are there. Basically, I prepare 2 routes. I got data which is not secured, and /auth is a secured route. So whenever I try to hit auth without logging in, I get a 401 and therefore need to authorize. So if I do a /data/get. This is what you see here is the consequence of a web handler I created. So the web handler, whenever I do a get, the web handler returns this. I use this information every now and then for debugging stuff, because it's sometimes interesting to see what's actually sent to the resource to pass, and this basically echoes what's sent to the to pass. We got a more advanced version which has all the information OpenEdge makes available to you as a programmer. Well, it's too much to go through here, but obviously we want to see our beloved customer table as well. Sports 2020 in this case. And over here is obviously the HTTP status code, which, since we're dealing with the non-authorized part, where I was requesting data/customer, I get a 200. Now, if I click authored customer, then I enter the secure part. So once I send this down the line, POS says to me, okay, I don't have any token, you're not authorized. So what I do, I say login. This could be automatically. Right now I've made a login button because it makes it a little bit clearer. And if you look at the URL here, we are no longer in the client application. No, we are. I don't know if it's the header says http keycloak.bfv.io, which means we are actually not in the client application here. We are in Keycloak. This is Keycloak is serving this dialog. Now, let's say I log in. Then I get back to the application. The token is handed over to me, and now since I have the token at the client application, normally this calls automatic, but because for this demo I have the token, and now I can retry to go to the authored endpoint, and then it says okay 200. So I handed over the token to pass did this entire thing, and it says okay, you're good to go. Now, okay, this is now a little bit of Keycloak. Now, this is what I'm going to hit here is the administration console. I'm no longer Bronco, but V, which are, by the way, my initials, if you're wondering where that's coming from. And if I sign in, I get the administrative console of Keycloak. Keycloak has the concept of realms, and realms, you can see realms, well, basically however you want, but from an ISV point of view, this could be your customer. So if you got 10 customers, you have 10 realms. And why was this interesting? Because per realm you can say, what identity provider do I want? So now let's show it a little bit. Over here I can configure my identity providers, and this gives you a pretty good idea what identity provider I can use. So these are the standard ones, but we can have Bitbucket and all the socials as well, even Twitter or X. Now, you can set up different clients. So if you have, what I set up right now is the PUC 2022 web client, but I could have just as made as well PUC 2023 app client, which has different requirements, because I know the app, I trust the app, but it is better in concealing the token I actually get, or the entire OAuth2 dance. So I can set up different requirements over there. But just as a little demo, over, here are my users, and well, let's add a user. Just see how simple this can be. That's where my trusted colleagues come in. If you're wondering why I'm using a keyboard, my laptop is broke. First name is Hans, and now I create a user, What I do next is, in this case, I set a password for Hans, and I set it to be Hans as well, because that simplifies things a little bit. Are you sure you want to change passwords? Yes, I do. Sorry? 5 minutes. Check. Right on schedule. Okay. Now let's log into the application again and say I want the secured route. I'm unauthorized, and I no longer log in as Bronco, but I log in as Hans. Now, I forgot something. It's live demo. It's always the same. One of the interesting parts is that I can, like I already mentioned, I can set up. Just a second. I created the right realm. Users, Hans. One of the things I forgot to set up, required user actions. Now, I don't want him to update his password, but what I do want to do is configure a one-time password. So I just say, configure a one-time password, and that's it. I save. Now, and just for the sake, I just going to log in as Hans. And then I get the dialog for configuring the one-time password. This was pretty easy. If you would have, so maybe Hans, if you are able to scan that and give me the one-time password. 702. This is the authorization part. So I'm handing over, I'm asking Hans, do you really want me to hand over the email address, the user profile, and the user roles, or whatever? This is the OAuth2 part I already talked about. And I say yes. And I say, okay, authentication succeeded. Now, this was just a setup. The next time he gets the username, password login, and then the on-time password. And then all of a sudden he has two-factor authenticated. We have two-factor authenticated our application, just as easy. From a PaaS point of view, there's nothing really fancy going on. It's just the same. It's just how you configure your authorization server, because that handles that situation, and that's what it's good for, because it's just a single purpose to serve this. Now, just a few more sheets about the tokens. Once you start programming the application, it's good to know that there are 3 types of tokens handed over to you. And the first one is the access token. What we are moving back and forward is the access token. And as I said, it's a good thing for the access tokens to be short-lived. So typically 5 minutes. Now, you don't want your users to require to log in every 5 minutes. So that's why we have a refresh token. With a refresh token, you can, once the time to live was expired of the access token, the refresh token can be used to automatically get a new identity token, access token. So if you say the refresh token is valid for like 30 minutes, then the user has to log in after 30 minutes. Well, that's reasonable. Not after 5 minutes. But the tokens you're moving back and forward, and those are the targets. If somebody is sniffing your HTTP communication, he sees the access token, and you're no longer handing him over a token which is valid for 24 hours. No, it's just 5 minutes. So within this 5 minutes, he has to do his job, and that's just another layer of security. There's also the ID token, and the ID token can be given back as part of the login dialog. It can be fetched separately as well, and that typically contains more information about the user, which you don't want to carry back and forth all the time. For example, the avatar. So if you have a base64 avatar, you can request the ID token, and then there is that. Program the client. I assume web-based technology here, a browser, but the keycloak.js is valid for if you program your apps in JavaScript just as well. It's a library. And once you configured where your authorization server, logging in is as simple as this. So this makes sure that what you saw, so handing over the delegating the login to Keycloak is just being done by this. It's just it. And the only thing which you have to configure is once you have a successful login, where do you want me to go? That's it. Well, that's pretty reasonable for something which is intrinsically pretty complex. There are wrappers for all sorts of web platforms. There's one for future reference if you download it. If you end up with trouble, it can cost a lot of time. Use these settings to make sure that everything which you can possibly let pass log, which is logged, and you're going to need it. From 12.6 on, we can do a revocation check as well, because these tokens are handed out. They are valid for 5 minutes, but let's say after 2 minutes you log out. Then the token is still valid, because it says it's valid for 5 minutes. Now, if you are logged out in Keycloak, PES has no way of knowing, except in 12.6, there's a way which is beyond this presentation, but there's a way to verify each time you get a call in whether the token is still valid. So if you're logged out after 2 minutes, then you saved yourself token exposure, valid token exposure of 3 minutes. And JWE, which stands for Java Web Token Encrypted. Now, I advise you, don't put sensitive information in your JWT. But if you really have to, or maybe from a legislation point of view, if you're a banking world, whatever, there are encrypted versions as well, which is Java JWE, and that's how it's called. Also from 12.6 onwards, which, well, not bad. Are there any questions? I'll make you want a beer desperately. Yeah.
So the configuration you were showing, they look like instance level configurations.
Yeah.
Do it lower level to redirect different web apps to different alt servers, for example, within the same resource server?
Not entirely sure if I understand what you mean.
Well, you can create a web app called Fred and one called Colin, for example, like you did using it before.
Yeah.
Create 2 web apps, auth-ed and auth-f. Yeah, and then you could direct them to different authorization servers because they're protected by different. Let's say you have to use an external authorization
Yeah.
for different resources.
Yeah.
To be able to configure it too. Would you be able to create 2 instances?
Yeah. Then I make another web app.
A web app.
Yeah.
Do a web app.
Yeah. You configure this part per web app. The question was whether you can use multiple authorization servers. Well, no. You just point to one. In one web app, you point at one authorization server. And if you need another one, then basically you're changing your security requirements, and that's why you create a new web app. So per web app, you deal with one security scenario. Just one thing, which has absolutely nothing to do with this presentation, but it is what I like. If you are interested in how I take these pictures, and if you want to hear how I end up in the BBC podcast, maybe tonight with a beer or something, and this is there for future reference. These are interesting resources if you want to go down this route. And don't try to do everything yourself. There's a lot of information out there. Use it, I would say. And that's about it. Thank you for your attendance, and have a good conference. Yeah.